Jerry Jones, my good friend, is the Astronomical League contact for the MAS. He also is co-coordinator for our observing program. So if you have questions about observing or ways to get into observing, Jerry's your guy. I know that he's a master observer, silver level. I didn't even know they had those levels, Jerry. I thought you either you were a silver or you weren't. But I guess now they have
All
levels
depends
for
on the
that.
color of your hair.
And he has a 15-inch Dob, as I recall, and
Many others.
Quest Star, and I think a C8. Am I right?
And a C11, and too many to count.
So normally Jerry's the guy on the observing field that's always busy looking at stuff and is in the zone, as it were. Anyhow, he's going to present to us today. I'm not sure how long it'll go. We're scheduled to go till 3, but it might end up shorter or a little bit longer depending on his material. We'll have a Q&A session at the end of that for general questions. But like I said, if you have questions in the meantime, just drop it in the chat, and I'll ask Jerry when we get a second. Well, with that, I'm going to turn it over to Jerry Jones.
Good afternoon, everyone. Thanks, Suresh. I'm going to sort of use a sawed-off shotgun today, and I hope that works well. Let's see if we can get this working. Can you guys see that all right?
Yes.
Excellent. And do let me know if something funky goes on. So a couple of months ago, Suresh invited me to talk a little bit about the Astronomical League Observing Projects and just how they work, what they look like, what their purpose is. And as I thought about that, I decided I wanted to do a little bit more than that. And I wanted to talk about organizing our observing evenings with and without the Astronomical League Observing Projects, mostly because I know that when I was starting, it was what would affect how well I did out in the observing field was how well organized I was, and what I was looking for, and what I had in mind, and all of that. And so what I want to share with you today is I'm going to share with you a lot of things that I've learned over the course of the last decade or two of fairly serious observing, and in the hopes that that I'm able to offer something to somebody. I'm going to be really kind of shooting an inch deep and a mile long. So there's going to be a lot of information. Some of it may not make any sense. Some of it make a little sense. Hopefully it will generate some specific questions. Each one of these topics that I'm going to talk about you could spend a great deal more time in. But before we get started, I want to share a little bit about the Astronomical League. Now, the Astronomical League is the parent organization for the Minnesota Astronomical Society. We have the Astronomical League is over 240 local amateur astronomy clubs all across the U.S., and they have a 3-part purpose. The first part is to foster astronomical education, to assist the communication among amateur astronomical societies, and to provide incentives for astronomical observation and research. And it's really that third one is where the Astronomical League projects really kind of fit in. So that's the Astronomical League is a rather important body and organization for all of us. Kind of makes us sound actually like superheroes. We're all members of the Astronomical League. Kind of cool. All right. So what we're going to cover today is, as I had mentioned, is really going to be kind of an inch deep and a mile long. And so I apologize if there's a lot of stuff that either doesn't make sense or does make sense, or it just kind of touches the surface. I'm going to make a lot of generalities. There are going to be some things, almost everything that I suggest today, there's going to be some sort of an exception. So especially those of you who have had some observing experience, be kind and gracious to me. Feel free to raise those exceptions. If I don't bring them up, that's perfectly fine. So I can tell already I'm having some issues. Okay, so one of the things we're going to talk about is I'm going to share a bunch of limitations or guardrails or things that affect or govern or have an effect upon our observational experiences. And these are the sorts of things that if you know about them and if you take them into account, they have a big effect upon what you're going to observe for a particular night or what you have in mind. The second thing we're going to talk about is some software that might help you organize, and I'm really having some issues here. I'm apologizing about that. Some software that might help you track your observations and organize them. And then I'm going to talk about two different organizational methods. One by locational, which is essentially by constellation, and one topical, which is essentially a particular thing that you can observe. So before we go any farther, oh, this is misbehaving. There we go. Why is this important? And the reason why I think this is important, because as beginners, we make mistakes that tend to create frustration, boredom, disappointment, all of the things that make us look at that telescope that's now gathering dust in the corner of our room and wondering, well, why did I even buy that thing in the first place? And so these are some of the mistakes. First of all, beginners often think that objects are easier or harder to find than they actually are. They also think that they can see more objects than they can. And interestingly enough, oftentimes skilled observers feel as though they can see less objects. They don't set their sights out quite far enough. Beginners really have no idea what to look for. They have no idea where to look. When they go out, and this is really a key. If this is your experience when you take your pair of binoculars or you take your telescope out or you just go out to the night sky and look with your naked eye, if you wind up looking at the same things each time, that's a key. And so any of these reasons can create boredom, frustration, and dissatisfaction. So first of all, before we go on, what are some of the things that we can actually observe? And really, the list is huge. We can look at stars, and there are lots of different types of stars. There are double stars, there are carbon stars, there are occultations by stars, there are novae, there are variable stars, and the opportunity of being able to do some real science via the American Association of Variable Star Observers. There are asterisms, which are groupings of stars that look interesting or different or particular. There are obviously deep sky stuff, open clusters, globular clusters, galaxies, nebulae, bright, dark, and planetary. There are asteroids, there are near-Earth asteroids, there are main-belt asteroids, there are Trojan asteroids, there are comets, there are meteors, there are Earth-orbiting satellites. There's the sun in both white light and hydrogen alpha. There's the moon, which is its own enormous situation, and there are the planets. And there's radio astronomy, and there's even spectroscopy. And on top of all of that, there's a type of observation that is historical in the sense that wanting to go out and experience the things that Galileo experienced, or Messier, or Herschel, or E.E. Bernard, or any of those guys. And so there are so many ways to organize and perceive just going out and looking under the night sky. It really, truly, the sky is the limit. So the real trick is to knowing your limitations, because your limitations will determine your observing goals. And so here's the list of things that I hope to cover in the next 4 hours. Just kidding. Scope size and type, light pollution, sight lines, personal eyesight limitations, phases of the moon, transparency and seeing, observational preferences, to hop or not to hop, logging and sketching, and finally the weather. So these are the 10 things that we're going to talk about. All right, let's jump into it. First of all, limitation number one, the telescope, the size of the telescope. The issue is not the diameter, but it's the area, because really what's happening, that lens or that mirror is gathering light. And then the eyepiece does something with the light. It magnifies the light. But the majority of the purpose of the telescope is to gather the light. And so it has to do with the area. And so if you take a look, if you take a look at a 4-inch telescope, it's got about 39 square inches of area, but an 8-inch telescope is 158 square inches of area. That's 4 times the area, even though the diameter is 2, it's 4 times the area. And so you can tell right away that there's something to this size issue, that the larger, the more light gathering you're going to have and the more stuff you can see. The smaller, that's going to be a limitation. But each one of these telescopes has a limitation in and of itself. And understanding that limitation will help you get to perceive just what is it that I can see. And of course, using binoculars adds both eyes, only enhances the experience and doubles the area. But as the size increases, so does the lack of portability. It increases in weight and increases in putting it in time together and all of those sorts of things. And we have to be aware that there is a particular disease that affects all relatively serious amateurs, and that's called aperture fever. And I like to think that William Herschel is really the first victim of aperture fever. Here's a picture of his first telescope. It was a 6-inch mirror. The length was about 7 feet. And during the course of, and this is the one that he used to discover Uranus. And in the course of time, he wound up with this. This is a 40-foot tube, and it's a 1.2 meter mirror. Was made of speculum metal, so it wasn't all that terribly effective. But what's interesting is that in many ways he had more success with this 7-footer, the 6-incher, and the one in between is 20-footer than he did with his 40-foot. Sometimes aperture fever gets you to a place where it's not exactly as cool as you had hoped it would be, but that's the issue there. All right, so there are 3 common types of telescopes. And again, my apologies if this is just kind of going over stuff for people that already know, but for those of you that might not have this information, I'm just going to go over this really quickly. 3 different types of telescopes: refractor, reflector, catadioptric. Refractor is typically the most expensive, typically has the best clarity. Typically, it's easy to haul unless it gets big. Typically, it's best for everything. The largest size in the world is 40 inches, and typically an amateur refractor only be from 4 to 12. A 12-inch telescope is refractor is pretty enormous, though. It'd be very difficult to carry around. Reflectors are typically the least expensive and typically the best light grasp because, since they are least expensive, you can afford more aperture. So a point being is that a 12-inch Newtonian reflector is going to be way less expensive than a 12-inch refractor. It's also the hardest to haul because it can be a bit awkward. It's best for deep sky objects. The largest reflector is 19 feet, the LTZ, which is the Latitude Zenith telescope, and was decommissioned in 2016. That was the one that was made of mercury, and so it spun, and that's how it created the spherical dish. But a typical size for an amateur is anything from 18 inches to 40 inches. There are 40-inch Newtonian reflectors, enormous. And the next one is a catadioptric, and that's a Schmidt or a Maxitoff. And again, this is very much of a compromise. It uses both a lens. The standard Schmidt does not, but the standard Cassegrain does not. The Schmidt Cassegrain and the Schmidt Maxitoff uses a lens here and mirrors. Here's a mirror, and there's a mirror there, and then the eyepieces are back here. So it's a compromise. It is in between as far as cost. Compromise. It's in between as far. Although some Maxitoffs are magnificently crystal clear. They rival many of the best refractors. Easiest to haul. It's a compromise. It's a compromise. It's a compromise. However, this design is the one that is used most often in the professional astronomical community. And the largest is 130 feet, which is the European extremely large telescope, which is set to have first light in 2027. Typically, amateurs are about 3.5 inches to 16 inches. But the important thing is the best telescope for anybody is the one that gets used and the one that's on a steady mount. So those are important things to have. Okay. Limitation number 2, light pollution. So this changes what you see with what you have. Now, this is what's called the Bortle Scale. It was initiated by John Bortle via the Sky and Telescope magazine, an article in February 2001. So it's been around for 20 years. It's not perfect. It's got some issues, but it's been sort of recognized as probably one of the best ways of seeing light pollution. And you're going to see, as we walk through this rather quickly, you're going to see your location marked in this. So there are 9 different levels, all the way from 1 to 9, 1 being excellent, 9 being intercity. And you can see, and over here, this is called naked eye limiting magnitude. So this is the magnitude of stars that you should be able to see, although 8 is there aren't very many people that can see 8 magnitude stars naked eye. This is the sky quality meter, which is a machine that gives a quantitative idea as far as light pollution. And those are machines that you can purchase. And over here is an essentially concept of what's seeable. So inner city, the sky is brilliantly lit. Only objects visible, the moon, planets, and maybe the Pleiades. And 8, the sky is light gray or orange. One can easily read from the light of the sky, even though you wouldn't want to. 7, the sky is entirely gray. Milky Way is absolutely invisible. 6, which would be considered bright suburban. Light pollution makes about 35-degree horizon glow all the way around. The clouds are quite bright, especially including high cirrus. Milky Way is maybe visible at the zenith. In a suburban, there's light pollution in all directions. The Milky Way is weak. So as you look through this, you're going to see a couple of keys. First of all, the key is whether or not you can see the Milky Way and how the clouds look. If the clouds are going to be quite bright up till about 4, the clouds are going to be quite illuminated, and the Milky Way has become more and more impressive. The clouds will become darker, and the Milky Way will become better until when you get to a real dark sky sight, the Milky Way is so bright it actually casts a shadow, and clouds are dark holes in the sky. And the only way you can tell a cloud is going by, and you look up and say, what happened to the stars? I don't see any stars. Well, that's because the cloud is in the way. So that's a basic concept and idea of this Bortle scale. Now, the reason why I share that with you is that anyone who lives downtown Minneapolis and just bought a 16-inch telescope and expects to see galaxies and all sorts of deep sky objects is going to be a little bit disappointed, primarily because of the issue of light pollution. All right, so here's our MAS sites based upon Bortle language. Eagle Lake is 4.5, Cherry Grove 4.0, JJ Casby 5, LLCC is a 3, Crux Meadow is a 4, O'Brien is 4, although there's a big difference between those two 4s. Okie-Tex Star Party is a 1, Texas Star Party is a 2, sadly downgraded because of all of the oil being pumped out of the ground back there. So there are a lot of lights, especially, unfortunately, by McDonald Observatory. And Stillwater Wildlife happens to be a 5. Now, there is a program called Clear Outside. It's a free program that you can punch in your particular location, and it'll give you a basic Bortle scale for your location.
Hey,
so
Jerry,
here's a map.
Jerry, can I stop you for a sec?
Absolutely.
Just want to catch up on some of the comments and Steve Emmert just mentions that all members of the MAS are members of the Astronomical League, and $5 of your dues goes to the Astronomical League.
And I was going to mention that at the very end. Thank you very much, Steve.
I mentioned that, as I recall, Herschel's largest telescope, the 40-inch, what it was?
A 40-foot, right.
Yeah, 40-foot, had very limited slewing. It only basically went up and down, right?
Right. Well, so up and down, side to side. No, it had up and down and side to side.
But I thought that it only had a few minutes of slewing action to either side. Like you could only view objects for a few minutes.
So let's go back to that picture. So as you can see, there are wheels on the bottom. And so it can turn around 360 degrees, and it has a pulley system. So it can go up to from about 30 degrees, probably up to maybe 75 or 80 degrees. And you can see the little guy sitting here. Whoops, sorry. And this is Herschel did not often use it in the Newtonian with a secondary and a Newtonian. So he did not often use it like this. He used it, he put the eyepiece right here, so his head was the only thing in the way. And the reason for that was that the secondaries were so badly formed, it actually took an enormous amount of efficiency away from the telescope to use it in a Newtonian reflector setting. So it was often used, I think this might be called the Gregorian focal point, but I'm not entirely sure about that. So it actually had a fair amount of flexibility. This is the same design as his 20-foot. His 20-foot had the same thing. It just was half the size.
Got it. And then Steve Everett followed up with another question, or another comment, that he hopes that you'll show your picture touching the lowest remaining portion of Herschel's 40-foot scope. It's on display outside the Royal Observatory.
Oh. Right? No, I don't have that. Sorry, Steve.
But
I did touch it. I did touch. Let's see. Can I go back to that? I did touch. It was probably, well, Steve saw it too. He was there. It was probably a portion that was in this case, but it was metal, and I did get a chance to put my hand on it, which is pretty cool.
And he follows up with saying that the speculum mirror is on display at the Science Museum of London.
Yes, it is. Yes, it is.
That's all I see in the chat for now. Does everybody have anything for the moment?
Yeah, I'm moving pretty fast here, so do not hesitate to stop me.
All right, all yours.
Okay, so so getting back to light pollution, here's a map of the color-coded light pollution. Again, you can find this on a program called Clear Outside on a Dark Sky Clock. And I'm not going to go through the different details, but you can get an idea. This is considered a 3. This is considered another type of 3. This would be a 2 over here. This is obviously a 9 here. So this is J.J. Casby. This is CGO. This is ELO. And this is LLCC. Now you can see why we have LLCC, because it is the darkest light, the darkest location that we have. And there are some things you can see at LLCC that you can't see anywhere else. But this brings up obviously the issue of, if you are in a place where you've got a lot of light pollution and you want to see more stuff, you need to think about issues of packing up your telescope, the cost involved, the time involved. And that also makes a difference what type of telescope you have. If you've got a 40-inch reflector, that's going to be way harder to carry around than an 8. But of course, you're going to be able to see more depending upon other factors. Okay, so limitation number 3, sight lines, what you can see from where you are. Now, typically, higher is always better and windier, and that can be an advantage or a disadvantage depending upon humidity. But the reason why higher is always better is because something called air mass, which is how much atmosphere you look through. So in 90 degrees, when we're looking straight up, you're looking through 1 air mass, and that's the least amount of atmosphere you're going to be able to look at. Obviously, it's the reason why we put telescopes on mountains, because when we look right up, there's less, the single air mass is much less, there's much less to it. But you can quickly see as you go down here, you get to 30 degrees and you've got 2 air masses now. And so what happens is the farther down you look, things are going to happen. The color of a particular object may change. The scintillation, which is the movement of the air, changes the color and makes it change in and out. You've probably seen this with bright stars like Capella. That's when it's low, it looks like it's changing colors and red and blue and green and all that kind of stuff. Well, that's the scintillation. It affects the seeing, which we'll talk about, the transparency, which we'll talk about, and it affects the observational magnitude, which is important for variable star observers. How bright is that star? If you're looking through 5.6 air masses, that star is going to be substantially dimmer than if you were looking through 90 degrees, only a single air mass. So this becomes one of those things. Depending upon where Uncle Ed's house is or Betty's house is next door, you may or may not be able to see certain things. And so sight lines become important. All right, limitation number 4, your own eyesight. What you see is what you get. Our hobby, observational astronomy, is really completely subjective due to the quality of the final optical element, which is our eyes. Now, there are amazing observers out there like Stephen O'Mara and Dave Tosteson, and there are some of our members of our people like Greg Halbrick and John Marchetti, they just seem to have great eyes. They can just see all sorts of stuff. And then there's me, that I just don't have all that great of eyes. And so that makes a difference in what I can see. So, but here are the eye issues: myopia, presbyopia, which is the lack of the eye's ability to focus, caused by a lack of flexibility in the lens. And that's typically fixed with glasses. So someone who has myopia or presbyopia may not need the lenses, your glasses, the telescope. But then there's also astigmatism, which is the lack of the eye's ability to focus the light to a single point, which is caused by imperfections in the cornea and the lens. And that's not always fixable, but with glasses. I need to wear glasses at the telescope just because I have such a nasty astigmatism. And there is a product called a dioptrics by Teleview, and I've never tried it. Supposedly that's supposed to help with astigmatism. And then there are cataracts, which obviously is the clouding of the lens due to age. but so the point here is that you need to have some legitimate expectations of what you can see. If you're 20 years old, you're going to see way more than if you're 70 years old, because your eye just doesn't open up nearly as wide. At 20 years old, it probably opens up the full 7 millimeters. I'm 68, and I think I'd be thrilled if mine opens up 5 or 4.5 or something in that order. So that really affects the things that I can see and how I go about looking at them. Okay, limitation 5, phases of the moon. First of all, those of us who happen to love deep sky objects need to develop a love-hate relationship with the big searchlight in the sky, because that's really what it winds up being. Point, however, is that there are thousands of things to see on the moon, especially if you utilize the terminator, the location of the terminator, and the concept of shadow. Amazing things that you can see. In fact, the moon is, for a lot of, I'm thinking of Patrick Moore, the late Patrick Moore. The moon was his favorite thing to look at. And don't hesitate to using different types of filters, not just filters that make the image dimmer, because it can be so flipping bright in the eyepiece, but also using color filters and UHC filters and those sorts of things. They will help you see things, changing the contrast, increasing the contrast that you wouldn't be able to see if you weren't using them. I did not believe this until I started using color filters on the moon earlier this year, and I was just amazed how much clearer and cleaner, like an 80A would the effect it would have on the moon. Deep sky objects are best seen between fourth quarter and first quarter. Obviously, the moon is more out of the way. Between first quarter and fourth quarter, it's best to observe less transparency dependent objects like multiple star systems, asterisms, planets, variable stars, carbon stars, some open clusters. But that doesn't mean you can't do it. So the point here is that if the moon is mostly full and you want to go out and observe, well, if it's mostly full, you're probably not going to observe the moon, because that's the worst time to see contrast, is the full moon, just is. But you will still be able to look at double stars, variable stars, multiple stars, systems, asterisms, planets, those sorts of things. So there are things you can do when the moon is out, and there are things you can't do. But just that understanding will help you determine what it is you want to take a look at when the moon is full or when it isn't, and decide, I'm going to wait for look at this when the moon is gone, and I'm going to look at this when the moon is full. Okay, next one. Again, sorry about that. Limitation number 6, seeing transparency and humidity. First of all, the definition of transparency is the amount of particles in the atmosphere. You've been outside when the sky seems so clear, and you've been outside when the sky seems so nasty, like when we had those wildfires earlier this year, the California wildfires. That's the whole issue of transparency. Oftentimes, transparency is best directly after a storm has passed through, especially like a good solid rainstorm. Deep sky objects are best seen when we have high transparency. Interestingly enough, poorer transparency does not necessarily negatively affect looking at planets or looking at double star work. In fact, some of my clearest images, visual images of looking at Jupiter, for example, has been through clouds, which is really weird. Sometimes if the sky is really stable, you can use an awful lot of magnitude. But if the sky is not stable, and I'll get to that in a second, but generally deep sky objects are best when it's transparent. Now, seeing is air turbulence. And the seeing is that twinkling, bloating caused by the waves of variation in the refractive index of the atmosphere. The atmosphere has a refractive index, just like a lens in a mirror has. In fact, the mirror the atmosphere operates that way. So when it's moving around a lot, you're going to get scintillation, which is the brightness variation caused by focus and defocus of the starlight. You're going to get poor seeing, which will require you to use less magnification, because magnification magnifies the disturbances as well. Oftentimes, deep sky objects are unaffected by poor seeing, because typically we use lower powers of magnification. If you're looking at galaxies, you're typically not going to use more than 150, maybe 200 power, unless you're looking at something very specific. But if you're looking at certain deep sky objects, typically you're going to use less magnification than you would if you're looking at a planet. And splitting double stars and planetary work will be negatively affected because those things require an additional lots of magnification. Okay, limitation number 7. I hope that made sense going through transparent seeing. We'll talk about it again a little bit as I talk about forecasting weather. So this is a funny limitation, but it's a true one. What are you most interested in seeing? This is going to inform how you organize your night and what gear you'll use. If you love looking at Jupiter, if that's really what you love looking at, and unfortunately now there's not as much time to look at it, but you're not going to buy an F5 necessarily, buy an F5 20-inch Dobsonian. You're not going to need that. It'll give you some resolution, but there are other telescopes that are going to be best off for looking at planetary. So this is the kind of information. Moon, planets, double stars require steadier seeing, use higher magnifications, and are best benefited from telescopes that have higher F ratios. So like an F10, or a Schmidt-Cassegrain with an F10, or a Maxitop with an F14, those kind of telescopes are going to best be benefited from wanting to look at planets, double stars, and the moon. However, deep sky objects, galaxies, clusters, nebulae, except for planetary nebulae, they oftentimes require a fair amount of magnification. They require more transparency because we use lower magnification, and we want more and more of those photons getting through the atmosphere. So the bigger the telescope, you're going to see better deep sky objects in a 40-inch reflector than you are in a 4-inch refractor. The bigger the better, the lower the F ratio is typically. Again, these are generalizations. I'm sure many of you out there, especially the Steve Emmerts of the world and the Sureshes of the world, are going, but wait a minute, but wait a minute. And those are all absolutely true. I'm just kind of giving you a broad brushstroke. So, but for most of us, we enjoy a lot of things, so everything is a compromise. But the point is that our interests will appropriately affect our gear and its use. And that's a question you ask, what do I want to look at? Okay, limitation number 8, to StarHop or to use digital setting circles or GoTo. But here's the real question. What do you want to spend your time doing? Do you want to spend your time getting there, or do you want to spend your time looking? And the important thing is that both are absolutely relevant, and they're valuable, and it changes. There are times when I love the StarHop, and there are times that I will choose to use GoTo. So here's the analogy. You're driving in the Twin Cities, and you're either using a map or you're not using a map. You're using with or without GPS. First of all, if you're not going to use GPS, you need to learn how to read a map. Second of all, then you need to figure out where things are in relationship to each other. If you think that Edina is next to Stillwater, you're going to have a really hard time trying to get from one to the other. And so much of this, it depends upon the number of street signs that you have available. If you have a lot of street signs, then in many ways, it's easier to use a map. But if there are fewer, it's oftentimes easier to use a GPS. But there is value in both. Beginning drivers are always encouraged to learn how to use maps. Beginning observers are always encouraged to learn how to use an atlas and to learn how to StarHop. Now, location and things like light pollution make a big difference to this. Sometimes in dark skies, it's easier to StarHop because there are more stars or more street signs. Although sometimes it can be way confusing because there are so many stars, you don't see the constellations that you normally saw. I remember my first nights out in beautiful dark skies, I kept losing Pegasus. I couldn't find Pegasus because there were just so many stars. It was kind of a cool experience until I figured out what to do. In light polluted skies, oftentimes it's easier to use digital setting circles or GoTo because there are fewer street signs. There just aren't that many stars around to hop from or to. So the whole issue, my apologies, why this is having a problem. The whole issue of learning how to StarHop is learning how to go from where it is known to where it's unknown. And to do that, you really need to know your gear. First of all, if you want to learn a StarHop and you don't own a Telrad is the best thing for StarHopping. Then you need to learn how to use your finder scope. Then you need to learn the field of view of your particular eyepiece and know the orientation of your telescope. As far as orientation is concerned, refractors and Cassegrains will take a star chart, and they will reverse it, mirror image. So they flip east to west. So if you wanted to look at that star chart, look at that page and match it to what you see in your eyepiece, you'd have to actually take take it and flip it around and like look through the backside of it. Is that me? Are we okay, Suresh?
Yeah, sorry, I had technical difficulty. I'm switching to a different tablet.
Haha, so that wasn't me.
Sorry, go ahead.
Okay. In Newtonian reflectors, they take the image and they spin it around. So east and west are reversed and north and south are reversed. So that would be like taking your chart and just spinning it around this way. But so that's important to know if you're going to StarHop, because you need to look at the map, you need to match the map to what you're seeing in your eyepiece and your telescope. And there are so many star charts to choose from. So here are some of my favorites. This is a page from the Uranometria 2000 Deep Sky Atlas. And you can see here is can I get there it is. You can see the outline of Sagittarius. Here's the handle. Here's the teapot. So this is the constellation Sagittarius. You can see there are a lot of interesting things to look at over here. There are some stars over here, and you have this grid pattern. This is a good reference. Star Atlas is not a great star atlas on the field because it's fairly thin paper. Here's a better one. This is the Interstellarium Deep Sky Atlas. And you can see now you can see Sagittarius. You can see here's the teapot over there. And you can also see how these two pages overlap a little bit. And you have all these different colors. And this really helps you understand what some of these things are. These are dark nebulae, and here are some bright nebulae. And each thing has a particular way of being described and looked at. And you still have this grid system. And the nice thing about this one is it's printed on more of a plasticky material. And so this is very, very effective out in the field, although this one is a little pricey. Here's a very common one, Sky and Telescope Pocket Atlas. You can see here again is Sagittarius down here. It's even marked for us. Lots of different deep sky objects. You can see the outline of the Milky Way fairly easily. This is a very popular one, and you can see I've used it a great deal, how my pages are thumbed and dirtied and all of that kind of stuff. So this is a great atlas. There are also tons of computer star atlases. These are most common: Sky Safari, Guide 9.0, Stellarium, which is free, Cartes de Ciel, which is free, and there are so many options for PCs and Macs and tablets. My personal choice is to use Sky Safari, Interstellarium, Guide, and Sky Tools. And so let me just give you an idea of what some of these look like. These are the star charts on Star Tools. And you see three different objects. Now I'm looking for right here, just as an example, I'm looking for NGC 6309, and it tells this is the naked eye view, and it tells me it's right here in Ophiuchus. This is the eyepiece view, and it tells me it puts it in the center. But this also now gives me some ideas where these things are. So I would put my Telrad right here. I would have this in my eyepiece and be able to say, oh, I see this set of asterisms. Oh, I'll line up my telescope so this asterism's over here, and this box right here is over here. And hopefully then 6309 is going to be in the center. And then here is the eyepiece view. And I can grab this and I can move it around so it matches the orientation of my eyepiece. I've already been able to determine what telescope I'm using and all that sort of thing. And so it gives me, and you can see, interestingly enough, here is this asterism. In my telescope, my finder scope is at a correct angle. So west is on the west and east is on the east. In the telescope, you can tell it's not quite the same. I have to make an adjustment of where west is. So that gives you an idea about that. Here's Guide, and this is not this. You can see there's Orion right in the middle here. And the cool thing about Guide is when you zoom in, you get many, many, many more things. So we will move on. So the question of this digital setting circles versus GoTo. Now,
Hey, Jerry.
original setting circles. Yes, sir.
Can Can I cover just for 1 second?
Absolutely.
I was off the grid for a couple of minutes or so. I might have missed a question or two, but Steve Emmert mentions that we have a link to the magnitude 7 star atlas on our BSIG forum web links for beginners topic. So we have what he's saying is we have the star atlas that goes out of magnitude 7 on our BSIG forum. That is a good free resource.
Fantastic.
And there's also planet spheres that you can put together.
Absolutely.
He likes the magnitude 7 star atlas because you can print pages out and put them into a 3-ring binder, as it were.
Yep. Yes, and there are so many free things available, and if you a person just does some research on the web as far as free star atlases, you're going to find a ton of them, a ton of them. Yes, so Steve is absolutely right.
Are there any other questions or comments for that part of the discussion? All right, back to you.
So the lack of questions either means that everyone is thoroughly befuddled or I am completely succinct and clear. I wonder which one it is.
You're succinct and clear, Jerry.
Yeah, right, sure. Okay, so digital setting circles versus GoTo. Now, setting circles, you can find them on some of the older German equatorial mounts, and they're actual circles. And on them, they show right ascension and declination, and that's essentially celestial longitude and latitude. Digital setting circles are computers with encoders on shafts that determine the position when you move your telescope. GoTo are encoders on shafts connected to motors that will move the telescope to a particular position. And both of them have backlit screens that tell you where your information. Some digital setting circles, you move the telescope and it makes the changes, gives you an idea where you are. For example, Sky Commander works that way, as do a few others. And GoTo, you generally, you go to a screen, you pick a particular object you want to look at it, you press the button, and you don't even have to worry about right ascension declination, and the telescope will move right to it. My personal experience in light polluted skies using digital setting circles or GoTo, because I find there aren't enough street signs. Like, for example, I am blessed enough to have a backyard observatory in my house here in Stillwater. Stillwater is a Bortle 5. I have a Celestron C11 in there. It's an alt-az mounted GoTo, and I find that there just aren't that many street signs around, so I wind up using the GoTo, and I punch in what I want to look at, and away I go. However, if I'm in a dark sky site, I love star hopping because I feel as though it gives me a sense of ownership to the night sky. But I do have a Sky Commander hooked up on my 15 when I take my 15. So that after maybe 15 or 20 minutes, if I still can't find what it is I'm looking for, I'll use the digital setting circle, and it'll help me find it. And that happens. Sometimes it doesn't, sometimes it does. It all depends on how faint and obscure the thing that I'm trying to find. But I always try to find it. And it's a skill. Star hopping is a skill.
Hey, Jerry,
okay.
Quick
Yes,
question.
Yes.
What's the percentage of the Astronomical League programs that allow for using the GoTo versus having to StarHop?
There are more that use GoTo than having to StarHop. The only ones I can think of off the top of my head that require you to StarHop is the Messier and the Caldwell. Everything else, I'm pretty sure you can use digital setting circles in GoTo. There are, however, a number of projects that will say if you saw everything with star hopping, they will put that on the certification. So you will get kudos if you star hopped everything.
Okay. It's been a while since I've been back on my double stars, so I couldn't quite remember if that was a requirement or if it was just a recommendation.
Not a requirement. Nope, it's not a
or
requirement.
If you just get extra gold stars for not using the GoTo.
Right.
Okay.
On some of them it doesn't matter. Some of them, but there again, it's more of an issue of why are we out there? Are we out there? Is it a treasure hunt? For some of us, it's a treasure hunt. For me, it's a treasure hunt. I like to go from where I know to where I don't know, and I like to be able to go, aha, I found it. There it is. I found it. Yep. It's mine.
Yeah, I agree.
But there are times when it just, and we're going to get to that in a second on this limitation. It's times where there's more things I want to do, and I don't want to spend all my time looking for stuff. I want to spend my time looking at stuff. And that's really where the logging and sketching comes in. Logging is keeping a verbal and written track of what you see for future and past comparison. And it's attempting to put words into what you see, which causes you to see more. It forces you to ask questions. What am I looking at? How big is this? How little is this? How bright is this? Does this take direct vision? Do I need averted vision? Is there anything else in the field of view? Is it elongated? Is it circular? All of these sorts of things. Logging requires you to ask those questions, and it makes you look more deeply. And there are specific questions for each type of object. And there's something on the observing forum, and I meant to find out and get a link, but there's something in the observing forum with a series of questions that are based on particular objects. And true, many AL programs do require you to write written logs. Now, sketching is keeping an artistic track of what you see. It really requires you to go past that. The word is supposed to be special. I don't think it's specific, it's supposed to be specific. Maybe I'll catch it the next time I click. It requires you to see more than just how, is it oval? There it is. Is it oval, or is it bright? Is it dim? That sort of thing requires you to more into the specific. And it really forces you to slow down. I remember reading a research paper once that suggested that in order for the mind, excuse me, to create a mental image, an image that you will remember when you close your eyes, you can see it in your mind's eye. It takes 7 minutes of staring to really see it. And so this is the real advantage of sketching. It requires really little skill, just requires a willingness to practice. And I am the patron saint of that. I am a horrible sketcher. I'm a horrible drawer. My kids, when they were young, we played Pictionary together. They used to love to play Pictionary with me, not because they liked the game or because they liked me, but because my drawings were so horrible. And they used to laugh at my drawings. And my drawings were the ones that got put up on the kitchen refrigerator because they were so horrible. So it is what it is. But it also helped provide a permanent documentation of what you saw on that specific date. And I think it creates a sense of permanent ownership, so that I go back and look at my sketches and I go, yep, that's what I saw on that particular date. And really all it requires is pencil and paper. Now, there are advantages to both of these, and the disadvantage is it takes time. If you're going to sketch, if you're going to log, you're not going to look as many things in the course of the night. You're going to see them more deeply, and that's going to take time. My personal conclusion that both logging and sketching, I recently finished the sketching project, and it really sold me on the value of sketch. So I sketch just about everything now. So I don't look at nearly as many things as I used to on the course of an evening. And that's okay, because I feel as though I'm seeing them better. Now, there are lots of computer programs that will aid you in logging. And the primary value of the software is just to help you to plan what you see, when to see it, and keep track of what you saw. And here are some examples. There's one called Astro Planner, 45 bucks, Deep Sky Planner, 75 bucks, Sky Tool, a little more expensive, 100, 250, Sky Safari Pro, which is a little pricier for the iPad and for the Mac, although the cheaper ones, Sky Safari, the cheaper Sky Safaris are magnificent, and they're not that expensive, a couple of bucks. My experience, personal experience, has been with Sky Tools 3. It's excellent in both logging, keeping track of AL lists, and observational planning. It has, sadly enough, excuse me, a fairly steep learning curve. The sky charts, as I've already shown you, are expansive and they're excellent. It can also control the telescope. Personally, especially when I'm in my dome with my C11, I use Sky Safari to control my telescope, because the charts are so outstanding and there's so much flexibility. And then I use Sky Tools 3 for logging and keeping track. And of course, as far as aiding your logging, a lot of people just use plain old spreadsheets. Biggest advantage, they're cheap, completely customizable as long as you know what you're doing. So here is an example of a page from SkyTools 3. Now I'll just go over this really quickly, just kind of give you an idea of what a computer program can do. So here's an evening. This is the name of my observatory. Here's my telescope, that's me. This is the moon and the sun. There's the sun going down and there's the moon coming up. This is the level of darkness. Here are the times along there. And this is height. This is degrees of height. Here's the list, AL planetary nebula list. Here are the logs that I've already completed, and I could click on one of those and I could pull up the log that I wrote. Here are whether or not I have observed this for this particular list. Now I've obviously already observed these two in particular, even though I have not observed it for this list, because in this particular list you have to do some special things. Here's the title, the constellation, RA and DEC, its magnitude, the size, some information about when it's going to rise, when it's best going to be looked at, SkyTools' opinion of whether or not I'm going to be able to see it based upon my location and my telescope and my eyes. And it gives me an example of an eyepiece that might do best. And you can see here again, it's got this, don't do it, maybe, oh yeah, you can do that. So this is really helpful. And I use this for all, if I'm able, for all of my AL lists that I do. Okay, last limitation, then we'll take some questions and I'm going to go on to the AL projects. Weather. We can't do anything about the weather, we can forecast it. But there are three basic tools: American, NOAA, British Clear Outside, Canadian Clear Sky Clock, and Astrospheric. There are others, obviously, everybody has their preference: underground, windy, skippy sky. There's also great wealth in being able to look at satellite data, real time, up to the minute, within about 5 minutes or so, satellite data. Aviationweather.gov and the GO satellite star.nestis.noaa. It's best to use all of these. Here's an example of what NOAA looks like. You can see down here, you've got also temperature information, weather information, and here's the cloud information. And this gives you a percentage of what NOAA thinks whether the clouds are going to be like. And I find this to be relatively conservative. So if NOAA is saying there's going to be 12 or 10 or 8%, I can pretty much count on that's true. All the rest of this, it's really uncertain. But you know, what do you expect for a quarter? It's free. You pay it in your taxes. This is clear outside, and this gives you a little bit more. It gives you the total clouds, low clouds, medium clouds, high clouds, and some other information about precipitation and temperature and all that kind of stuff. It gives you yes, you can observe, maybe you shouldn't, no, don't observe, a kind of a stoplight effect there. I find that this is sometimes effective and sometimes predicted, appropriately predicted, and sometimes not. Sometimes it's way off. Here's the clear sky chart, which we're probably all familiar with. Now we're going to get into a program that is helping us understand transparency and seeing. And so you get an idea, obviously, during this time of when I generated this, which would have been Tuesday, the transparency and seeing were pretty lousy, even though there weren't that many clouds in the sky. That tells you something. And Clear Sky Chart added this past year a smoke, which was really helpful when it came to having all of the wildfires that we had. So this is really, again, all this stuff is super helpful. Fairly accurate predictively, sometimes not, sometimes yes. And again, these are all computer models. This is Astrospheric, and I find this to be one of the best predictors, especially if you purchase the upgraded and you get the all three different models that we'll put with you. But here again, we have cloud cover, transparency, and seeing. You get some weather information or wind information. You get some temperature information. Here's the moon and the sun, and it tells you when the International Space Station is going to come over. And it also gives you an idea of if you're looking for aurora, what the potential chance of seeing aurora. So I have found I use them all. and it just makes it really helpful. The top part is their prediction of what the clouds are going to look like, and you can move this forward and backward, which is kind of cool. And sometimes it's really dead on, and sometimes it's not. Okay, that's the end of the first part. Any questions?
I don't see any questions listed. I just see some comments. Steve Emmert had mentioned that some of our club's big Dob have Argo Navis on them.
Yes.
And less expensive ones for people that consider would be Sky Commander and Nexus DSC.
Yes.
Let's see. He also mentioned verbal logging using a digital recorder. Remember Nancy Rauschenberg used to use that?
Yep.
And so that's another way of recording your observations.
Yes, the only downside of doing verbal is then you're stuck with listening to hours of your own voice.
Yeah, that's true. Just our own vernacular, as you know, Jerry, we refer to those three weather websites as the Brits, the Canadians, and the Americans.
Right.
Because that's where these sites come from.
Right.
We can apparently get upgrades for, I think this is for Astrospheric through APP.
So it costs $1 a month. And what happens, I didn't, because I pulled it off a device that I don't have that. It does give you all three. And so you can go back, you can go into a little more deeply and take a look at, and it's the prediction for the cloud cover. The prediction for transparency and seeing aren't changed, but cloud cover is.
Hang on a second, Jerry. Jerry, you can get, just let everybody know, through Astrospheric, MAS members can, through using the subspace little icon on the app, can request to join the MAS, and then you get the upgrade for free.
And I need to talk to you about that, Mark, because I did that and it didn't work.
Yeah, well, we can work that out.
So I should also mention about Astrospheric that it has a really cool smoke map.
Yes.
Just like the cloud map. And it's very helpful, particularly in the summertime, so you can find where the smoke layer actually is. And then Fred Haggerty has an actual question. How do you find the Bortle for a location?
So I have found the simplest way is to get the program called Clear Outside.
Yeah, Clear Outside. Doesn't Clear Sky Clock have it? A Clear Sky Chart have it as well?
Yes, it does. But the difference is the Clear Sky Chart will give you the Bortle for a particular location. Clear Outside, you can punch in your own specific address, and it will give you the Bortle. It'll give you the Bortle.
Perfect. Any other questions, guys? Back to you, sir.
Okay, great. Hope I'm doing okay. All right, now this portion of it is a little shorter. Okay, so methods of organization, locational and topical. Obviously, locational is observing by constellation. And this is the most common method of organization. All star charts are organized this way. You open up a star chart and you're going to look at a constellation. You're going to see everything that's available in that particular atlas of what you can see, or even using Sky Safari. You zoom in a particular place and you're going to see what's there. And this is really helpful if you have issues with sight lines or those sorts of things, or light pollution or those sorts of things. Other elements that define this, it helps to understand if you've got good transparency. You're going to look at a star chart and you say, oh, I can look at deep sky. Or if the transparency is poor, okay, where are the double stars that I want to look at? If the seeing is good, I can use lots of magnification. I'm going to go that way. In truth, if the seeing is poor and the transparency is poor, it might be most beneficial just to go read a book. Planisphere is a necessity, a star wheel. There are lots of articles and books by Sue France, Stephen Merritt, guys like that work specifically on the whole issue of what can I see in X constellation. Star atlases, I've already talked about those, multiple free planetarium programs, Sky Safari, Sky Tools, Deep Sky Planner. They all help to ask the question, what's up tonight? So that is, without a doubt, the most common, the easiest, simplest way to organize your observing, allowing those 10 limitations to inform what the sorts of things you're able to do in general and able to do specifically. And because of the sight lines I have here at Stillwater, this is oftentimes how I do it. I know that I'd like, for tonight, I'd be able to see Gemini and a few other constellations around it, then I would focus on that. Unfortunately, it's been so cold and so cloudy. Okay. Organizing your observing by topic. And this is really where the Astronomical League Observing Projects really come in, because they are all designed based upon a project, a topic, a concept, an idea, an element, those sorts of things. And they obviously they span the entire sky. Typically, when you observe topically, you have to have larger sight lines, because if you're going to look at globular clusters in the summer, for example, you're going to want to look in multiple different places. One of the really cool things about using Astronomical League Observing Projects is that they help you observe things that you never knew existed in a particular subject area. And it helps you go deeper than you ever thought possible. When I started the open cluster list, for example, I had no idea I was going to be, I had to look at 125 open clusters. Now, if someone had told me, how many open clusters do you think you can see in Stillwater, Minnesota? I would have said, I don't know, 20, 25, maybe 50. I could see 125. Some of them not very well, but they're there. My point is that I would never have gone that deeply if I had not taken on the open cluster project. And there are advantages to goal-oriented observing, especially for those of us who tend to be a bit more goal-oriented in the way we deal with our lives. There's recognition for your work. There is a certificate and a pin for display, and it helps you keep track of the progress you've made. I can go back and I can look at my log books. I can go back and look at my sketches, and it's all there, and it's all organized and based upon the particular project that I was working on. And it really helps strengthen your logging and your sketching skills. And this is a major issue. If you want to become a better observer, AL lists is a major way of becoming better, because it will challenge you. It will stretch you, which is awesome. Now, really, you can do the AL lists and not hand them in. There's no reason why you should hand them in unless you've already done the work and you want to get a certificate and a pin. And then why not? But obviously, they're there for us to use. We don't necessarily have to get the certificate and pin. We can do the work. All right, so here's a list. This is actually a rather old list of most of the AL projects. And just let your eyes scan across that list and note which ones you find interesting. Like, do you find the galaxy ones interesting, or the lunar ones, or maybe the Caldwell, or the ones that are connected to with binoculars? There are so many here, or the planetary ones, or the ones that have to do with the sun, or there are so many. To date, there are 62 separate projects, and they include both visual and imaging, which is pretty cool. That's something that has been developed. In fact, now there is a master imager level. So not only do you have a master observer, but now you also have a master imager. I think that's very, very cool. And I'm really pleased that AL has gone in that direction. So there are so many. Where do you start? Well, one way is just look at the list, get on the website, thumb through the list, find somebody that's interested you.
What do you want to do? Do you want to play?
Do you want to play?
Let's play. Somebody, I think, needs to be on mute.
Ah, okay. I'll keep going until you yell at me to stop.
There's just a couple of comments, Jerry.
Sure.
Let's see. I'm not sure if you have every
no.
If that list is fully updated, because I know Tune of You is a really good list for people that are into like deep sky galaxies and the like.
Nope. This is not updated. This is a number of years old. I just had the screen. I had this list from when I made a portion of this presentation at an MAS meeting, I don't know, well, longer than 2 years ago. If you count them, there are less than 62. But when I counted them just a couple of days ago, there are 62 different projects.
Okay.
But this was just a kind of feast.
Steve Emmert was going to see if you were going to mention the book Objects in the Heavens by Peter Buren and Nayuki Kurita.
Nope, not today. But thanks, Steve. That's a great book. It's a great
That's
book.
all I have. That's all that's in the chat. Anybody have any questions?
Oh, Steve,
Back to you.
Great. Thanks. I have it. Actually, I have it right over here. Aha! There it is. Object in the Heavens. It's a great book.
Yeah, Jerry, I found it's really good because I am lousy at planning my observing sessions. And with that thing, I can go into a constellation that I can see and say, okay, that's the bright stuff. That's not the not so bright stuff. And it's right there.
Yes, absolutely. In fact, the few times that I've done NOAA constellation, and that's been the whole point of to look at a constellation and see what's there. This is the book I've used. Because you're absolutely right. This is, and I'm glad you brought it up, Steve, because I didn't even think of it. This is probably a #1 source for someone to say, I want to look at Ophiuchus tonight. Well, not tonight. I want to look at Gemini tonight. What's there? This is it. So thanks for bringing that up, Steve. Really appreciate it. Objects in the Heavens, Peter Buren, Birren. Okay, awesome. So grab what's interesting to you, despite the difficulty level. Doesn't matter. Do it, enjoy it, do it as much as you want, go for it, have a great time. And you will be stretched. You will be amazed at how much more you can find. Or you can choose the longer route. And that's understanding the whole Astronomical League Master Observer Program, which is what I'm about to go in right now. So before 2015, there was just this one award. There was the Master Observer Award. And it's been around for a very, very long time. After 2015, the powers that be decided to integrate more of the observing programs. They decided to create a logical progression from beginner to expert. And they wanted to make the Master Observer progression meaningful, not just a bunch of certificates pins. And that makes complete sense to me. And they wanted to recognize people who are willing to take on the depth and the breadth that observational astronomy represents. Remember that first list that I gave you of all of those things you can look at and all those things you can do. People that want that kind of breadth. This was the whole thing. They want to recognize and honor people who are crazy enough to do that. So here's the progression. You can see that the Master Observer is still sitting out here, but this is the standard progression now. Observer, Advanced, Master Silver, Gold, Platinum, and Binocular Master is all on its own. We'll talk about that in a bit. So here's the process. This is the typical process for someone who says, you know, I'm just getting started. I'm going to be doing this for a very, very long time in my life. I figure that, you know, I've got 40, 50 years left to live, and I want astronomy to be a part of that as long as I possibly can. And I just want to take my time and really enjoy observing and observe as much as out there. Then this would be a great process. You start with the Observing Award, then your Master Observer, then Advanced, then Silver, then Gold, then Platinum. And the Binocular is separate, and I'll get to that in a second. So here are the requirements for the Master Observer. 5 observing programs. 4 of them are required. And I think this is kind of cool because these are 4 things that really give you a good grasp on the beginnings of observing. First of all, Constellation Hunter, where you have to sketch, I think it's 35 different constellations. This is all naked eye. And you sketch what you see. And what a great way to, 25, sorry, there it is. This is a great way to get started, begin to learn the map of the sky. Next one is Honorary Messier, where you need to learn how to StarHop, or Binocular Messier, which requires you to StarHop anyway. Lunar Program, 100 objects, really easy to, this is really a fairly easy project. There's naked eye elements, there's binocular elements, there's telescopic elements. The solar system then, 25 different projects that give you a really clear idea of what's going on out there in the solar system. Then you choose from one of these, either Galileo, Universe Sampler, Two in a View, Beyond Polaris, Sky Puppy Sketching, Urban Observing Project, or the Youth or Astronomer. Sky Puppy is for kids 10 years old and younger. Youth Astronomer is from 10 to 17. Then requirements for Master Observer, which is a 10 total, so it's 5 more. Now, this you'll find is interesting. So the lunar you have already done. If you did the observer, lunar you will already done. In Messier honorary you would have already done. So you already had 2, and if you did the binocular as well, that's there. Double star, which teaches you how to understand position angle and how to split double stars and how valuable double stars in the night sky. This is the big one, the Herschel 400. This is the one that a lot of people stumble on because you've got to find 400 objects, and a lot of them are faint fuzzies. But you can do it from around, not so much from inside Minneapolis, St. Paul, but you can do it like from CGO easily, or from ELO. You can do it from there. You can do it with an 8-inch. You don't need a huge telescope to do it. But it takes endurance. That's the big thing for the Herschel 400. And then you choose 5 of any of these. Actually, you choose 5 of any of them, any of the 62. And these are the more common ones: Caldwell, Sunspotter, Open Cluster, Deep Sky, Binocular, Globular Cluster, and Carbon Star. But it could be any other 5. And then you wind up with your master. And then the requirements for Advanced Observer, which is a total of 15. You get your Observer Award, then your Master Award, then 5 additional. And this is the list. You have to choose from this list, and then from the either binovariable or variable star, either hydrogen alpha or sunspotter, either planetary nebula or southern planetary nebula, and then any one of those that are listed: active galactic, ARP galaxy groups and clusters, that sort of thing. So all you need to choose is 5 from this list, but it needs to be from this list. And you get that, and then you have your Advanced Observer requirements for silver, total of 20. The specific requirements get much less, but you must include, for these, you must include Lunar 2, outreach any level, sketching, and sunspotters. You just need need a total of 20. Then the requirement for gold, total of 30, have to include those. Outreach to stellar, Herschel 2, 400 more. Hydrogen alpha, stellar evolution, which is really easy, and variable star or binocular variable star for a total of 30. Platinum, total of 40, you kind of get the idea. So if you are interested in doing this, it's really beneficial to kind of look from the beginning to the end, or from the end to the beginning, saying, well, I want to do this. So, kind of create your own curriculum of things you want to see, as well as things you kind of have to see. Frankly put, I would never have done the sketching project if I hadn't had to have it for the silver, but I am so glad I did. I learned so much about sketching and about the importance of sketching and the value of sketching. I would never have done that. I probably wouldn't have done 125 open clusters either if it hadn't been required, but I'm really glad I did. I saw some of the coolest open clusters that I had never seen before. Beautiful asterisms within them, different colors, the whole 9 yards. There's real value in that, but it does take some curriculum planning. Okay, so the binocular master, a little more straightforward. AL has 9 binocular programs. You need to complete 8 of them. Typically, those of us up here will complete just the top 8, and will not, obviously, will hold off on the southern sky binocular. But some of them are fairly easy. Bino double star is fairly straightforward. Advanced double star is very difficult. Bino Messier, straightforward. Bino variable, straightforward. Deep sky bino, straightforward. Galileo program, straightforward. You already get the lunar bino if you've done lunar 1, and the solar system bino. There's just not much additional work if you add that when you're doing the solar system. So this is a fairly easy master to get. Yes, sir.
Sorry, if you go back a couple of slides to where you had the Messier and the Caldwell list. There it is. You might want to mention like what kind of telescope to use, because I think for the Caldwell list, you would need probably a 6 or an 8 at least, right?
Yes. Now the Caldwell is a bit more challenging. There are so Patrick
And the Herschel
Caldwell
400, you
Moore,
probably need an 8.
Patrick Caldwell Moore decided to, this was on a total on a lark, sent a letter to Sky and Telescope saying, hey, what about another type of Messier object? Or they may have contacted him. I'm not entirely sure on the genesis of it. But these were 110 of his preferences, his favorite ones and they include various things. Some of them are so freaking easy to find. Some of them are so freaking hard to find. And you need to find 70 of them. You can do it with an 8. You can do it with an 8 and skies like LLCC. You can do that. That would not be a problem.
What would you recommend for the Herschel 400?
No less than an 8, like a Schmidt-Cassegrain, and skies at least as good as ELO, CGO, LLCC. Some of the Herschel 400 are bright. The biggest problem with the Herschel 400 is there are 14 billion in Virgo, and it's very easy to get confused. And so the larger a telescope you have, the easier it is to find them. They jump out, but you can use GoTo on Herschel 400. So really, if someone just wants to check that off their list, I mean, they could do all of it. They can do, I think there are like 150 of the 400 in Virgo. You could do,
but that's blasphemy.
All those in 2 nights. You know, I mean, if you were just totally banging through them and just clicking them off, it kind of ruins the point, I think. I would, every single one I would log and I would say what I saw. Some of them I sketched, a lot of them I didn't.
Great. Does anybody have any questions about this part of the presentation? These lists or how to get started or anything like that? Any questions out there?
So I'm almost done.
So Steve Emmert asked, aren't there a lot of very southern objects in the Herschel 400? No, Steve, there's not. Because these are objects that Herschel found from England.
Right. Right. Now there are objects that his son found, and those are in the NGC list. But
those aren't part of the 400.
But no, but they're not, and they're not even part of the Herschel 2. Herschel 2 is all northern, and now there are some in the Herschel certificate, which is observing 2,500 of the NGC New General Catalog articles items. So I think there are some of those. But that's not that is an AL recognized thing, but it's not, you don't get a certificate or a pin for it. And Dave Tosterson recently finished that, which does not surprise me in the least. Okay.
Any other questions, guys?
Maybe I missed it, but how long do you think it would take to do the Herschel 400 if that was the only thing you were concentrating on?
2 years.
Yeah, a couple of years. Because it's all over the map. It's all the seasons. And yeah, so a couple of years. I think it probably took me 3. I could look. I have a beginning and ending date on all of my.
Yeah, one of the nice things about the Herschel 400 is probably at least half, maybe even 3/4 you can do from a suburban sky, but you're gonna have to do probably 100 of them or so from a darker sky.
That's correct.
So you'd have to make the effort.
That's correct. That's correct. Yep, absolutely. Yeah, so it's a great list. There are a lot of galaxies. There are a lot of faint fuzzies. So it takes some endurance. You, especially especially going through Virgo, it's, oh, I just saw that one. No, it's a different one. Look carefully. Oh yeah, it is different. Oh,
okay, Virgo was fun.
Yeah, well, yeah. See, it's similar to going through the list of the Messiers. In Virgo.
Yeah.
But it's just crazier and more.
4 times more.
Right. So, so here's the list of beginning projects, and this is according to the Astronomical League. So these are beginning projects. These are things that anybody can do. It doesn't require additional information. Alternative constellations, learning about constellations from other cultures. Beyond Polaris is information about how to read the night sky, right angle and deck, position angles, those kind of things. It's just really, really great information. Carbon stars. Carbon stars are fun to see, and it's beneficial to have a little bit of light pollution because they're red, and you need some of your cones. So if you're totally dark adapted, you're not going to be able to enjoy the carbon star list nearly as much as if you had a little bit of your cones operating there. Constellation Hunter, we already talked about. Dark Sky Advocate is not necessarily observationally oriented, but you get connected with the IDA, and you have to do some particular projects. Library Telescope, putting a telescope in your local library. Lunar One, we've talked about meteor observing. Everybody's watched Meteors Outreach. It's just a formalized way of getting some recognition for what many of us do normally. Sky Puppy for kids under 10. Sketching, we already talked about. My opinion, it's not, that one's not necessarily beginner. But then again, I'm a lousy sketcher. Solar System, I think, is also somewhat intermediate. Stellar Revolution is easy. Universe Sampler, straightforward. Youth Astronomers from 10 to 17. Here are a bunch of intermediate projects, and you can see there are quite a lot more of them. And they're all over the map. You can just kind of let your eyes feast on that list. There are some of them I think are easier than others, like Bino Messier. I think that was Bino Messier. If someone were to ask me, all right, I want to do this thing, what's the first one I should do? Excuse me, Bino Messier is the one that I would suggest. It's most helpful if you have 15 by 70s, but even 7 by 50s will work great. You can see a lot of them with 7 by 35s, but a little harder. But that teaches you the sky, teaches you how to StarHop. And I remember starting that project thinking, I'll never see 50. I was blown away. I was able to see more than 50 Messier objects with a pair of binoculars, crying out loud. So that would be one that I would suggest first is Bino Messier, but they consider it an intermediate. I don't know why. Double star, I think is fairly straightforward. You don't need a huge telescope to do double star. You need some thinking because you have to learn how to do position angles and learning how to split them and learning how to use magnification and all that kind of stuff. Lunar 2 is quite a bit harder than Lunar 1. Messier, I think, is I mean, even why they put it there and they put it under Observer Award, I'm not entirely sure. Sunspotters, I think, is a fairly straightforward one. You just you need to get sunspots, which we now have more. So these are the intermediates, and 2 in a View is a great one. Urban is a great one. Especially because it's designed to be used in light polluted skies. So and here are the advanced. And these are pretty tough. ARP flat, Herschel 400, Herschel Society certificate. That's the one that's 2,500, viewing 2,500 of the NGC new general catalog. Dark nebulae, which you need dark skies. There is no way on God's green earth you're going to see dark nebulae unless you're in a dark sky site, and the transparency is fabulous. They just don't show up. Galaxy clusters, Herschel 2, local galaxy, radio astronomy, spectroscopy. So that moves me into this next level, which is pretty cool. There are projects that aren't specifically observationally oriented, like Analemma, which is the figure 8, or the kind of crazy looking infinity sign that the sun makes, the motion of the sun across the sky during the course of the year. Then you learn how to chart that. Beyond Polaris, which I've already mentioned. These are all ones, Galileo programs, which are stepping in the steps of Galileo. So the requirement there is your telescope can only use 20 power, You can't use anything more than that because that's all Galileo had to work with. And there are a number of NASA Special Challenge programs. So that's pretty cool. And they're really kind of fun. So this is my list for the best for light polluted skies. Any of the double star programs, Lemma, Asteroid, Carbon Star, Jupiter, Multiple Star. I finished the Multiple Star recently. That was a magnificent project. It's not easy, but I did most of them from my Bortle 5 skies here in Stillwater. Planetary nebula. The interesting thing about planetary nebula is that many of them pop because they're oftentimes just slightly green. And so you look at a field of view in your eyepiece and you can tell, yep, that's it. Just because it has a different, it's oftentimes not stellar, it's non-stellar, and it just has a different sense about it. So I find I can see many of the planetary nebula, not all, but many of the planetary nebula from my skies here. Sketching, stellar evolution, asterism, variable star, hydrogen, obviously the sun ones, lunar, obviously the moon. And I didn't mention the new one, stellar lunar evolution, which I think looks very interesting. Occultation observing, radio astronomy, for those of you who are interested in listening to Jupiter, solar system, and urban. These are all ones that can be done in light polluted skies.
Jerry,
So,
on the multiple star one,
yes.
What size telescope do you recommend, or what's the minimum?
I think the minimum on the website is a 6-inch or an 8. I found, because that is a project that requires magnification, really what you're doing with the multiple star project is you're looking at groups of stars. These are all gravitationally bound groups of stars. So they're not asterisms that are not related to each other. They're groups of stars that are related, gravitationally related. And you have to parse them out. What you get on the list is you get obviously RA and DEC, and then you get how many members. Sometimes there are five members. Mostly the minimum is 3, 4, 5. I don't remember if there are any 6. There may be 1 or 2, 6 members in this list. And then you get position angle, and you get distance, and in seconds. So you need to understand the field of view of your eyepieces in seconds. And so then you take a look at what you see, and then it's a detective game. You say, okay, where's A? That's generally easy because generally A is brightest, but not always. Sometimes beta, alpha is oftentimes brightest, but sometimes beta is brighter. And then you figure out, well, okay, so that's beta, okay, that's gamma, that's delta, that's epsilon. And so you just kind of figure it out. Some of them you can do in 10 minutes. Some of them I've taken 45 minutes to an hour to figure out. And so it really helps to have a telescope that tracks. You got to have a telescope that tracks for the multiple star project. So I found best that my C11 was a perfect instrument for it. I would do it with an 8. I think it'd be tough with less because you can't get enough magnification and enough resolution. The biggest advantage of size when it comes to things like planetary work, solar system work, double star work is resolution. The bigger the telescope, the bigger the light gathering, the bigger the chance you're going to be able to resolve distances. You're going to be able to get more arc minutes or arc seconds. And that's what you need for that project. Does that answer your question? Probably more than you wanted.
Yeah, it was great. Thanks.
If you want to receive a certificate and pin, you need to become a member of the Astronomical League. And that is automatic for us as MAS members. Thank you, Steve. We really, really, truly, greatly appreciate your effort on the whole membership thing. And you've done it for so many years. I just am amazed.
So Steve Collins has asked a question. Where are specifics found for these projects? Trina then put up a link on the chat for people that are interested. I'm not sure. Does that go to the Observing Clubs, Trina, or does that go to the actual project lists?
It goes to the entire list where they have to pick which one they're interested in. And then within there will be all the information that you need
Thank you,
to
Trina.
get started.
Great. And then somebody asked, is the position angle easier to measure with an equatorial mount rather than alt-az?
What's difficult with either, what's necessary with either is knowing where west is. And when you know where west is, then you know where north is. And when you know where north is, then you know where 0 is. And then you also know where east is, and now you know where 90 is. And so, so if you have an alt as, it doesn't matter if you're using an alt as that tracks. You need to be able to turn off the mount so that you watch the star drift. And whichever direction the star drifts, that's west. And once you determine west, and if you know the type of telescope, if it's I'm going to screw this up. If it's, no, I'm not going to even try because I'm afraid I'm going to screw it up. I have to look at this up all the time. Depending on the type of telescope, either north is going to be to the left or to the right or west. 90 degrees, of course. And then once you determine that, then you know 0, and then you can go from there. If you Google eyepiece position angle, you will find a PDF of a clock face, not a clock face, but of the 360 degrees, and it's meant so that you can cut it out and stick in an 1.25 inch eyepiece in. And so then once you determine west, now you know north, then you just arrange this piece of paper. I put mine on plasticized cardstock so I could take it anywhere I wanted. And then so I just arranged that so north and 0 are matched up. And now I know the position angle. And then the way you determine the position angle is you start with alpha, the bright star, and then wherever the next star, whether if it's 2 stars, the beta, wherever that line points between alpha and beta, and you follow down to your guide, which is outside of your eyepiece, and that'll tell you the position angle. So it takes a little practice, but once you figure it out, you can get within 10 degrees, sometimes even 5 degrees, just by eyeballing, as long as you know where north is. Because you can guess, I mean, just put a clock face there. 3 is 90, 6 is 180, and 10 o'clock is 270. And so you just kind of figure it out from there.
Hey, Jerry, Don Gadzik put a resource on there on how to determine which is left and right and left. Don, do you want to talk about that real quick? Is Don on? Maybe he's on mute. Oh, he has no mic. Okay, so Don put a resource out there, best doubles at .wordpress.com, and it says left is right and right is left, a simple user's guide to PA.
Fantastic.
So for people that are interested, just click on that link.
Fantastic.
Thanks, Don.
That's great. Thank you, Don. Choose a project you're interested in, or in the sequence if you choose. Look through the guides, the guidelines. So on the Observing SIG forum, you will find a guidelines for AL observing project submissions, and I really encourage you to follow that. And it'll tell you what to do with your logs, how to write a cover sheet, all that kind of stuff, and that will help me greatly when you send it to me. And unfortunately, I tried to make my email address a different color, but it didn't go. My email address in ghostly letters is jjones7777@aol.com. Send me copies. The process is essentially you send me copies, I look through them. If I can make the call on them, I do that. If I don't, I check them through, make sure that they're in good shape, and then I send them on to the national coordinator. And typically, national coordinators, when I send them on, typically they just kind of rubber stamp them. But some of them, like the multiple star project one, the guy who runs that, he looks through every single log, and he sent me back the most detailed response I've ever had from the national coordinator. It was great. I really learned a lot about how I did and how to do better. It was really great. And then typically our certificates are in pins. are presented at monthly meetings, which is really fun. Hopefully we'll get back to our in-person meetings. At this point in time, I just have the national coordinators send them to people's homes. But once we get back into our meetings, then I will ask them to send them to me. And then I get to present them at a meeting. So in summary, anything you want to observe, there's an AL project. They help you organize your observing. They show you stuff you've never seen before. They give you a sense of accomplishment. And boy, did they stretch your observing muscles. Oh my word. All of a sudden you have to observe things that you never thought you could, or maybe never wanted to. And all of a sudden now you have to, and that's okay. And it really does give you a sense of well-roundedness in your observing. Questions?
So before we get to that, I just have some public service announcement. I do want to say real quick, can you everybody see what a font of knowledge Jerry is on this stuff? This is an amazing job that he did summarizing this for everybody. Now you would think with such a presentation, Jerry's been doing this 100 years, but when I first met Jerry, what, 5 or 6 years ago, you were fairly new at this, weren't you?
I started in 2010.
Yeah.
I had loved the night sky. I mean, I remember, like so many of us, I remember looking through Saturn with my Sears 2-inch telescope that I got for Christmas that year. I fact, I still have that one. How funny is that? But of course, like so many of us, life happens, career happens, family happens. And when my wife and I spent most of our time in Duluth, we came to Stillwater in 2004, mucked about until I discovered MAS in 2009. And so 2010 is when I said, you know, I am going to get my observing legs back. And so that's when I started. So I've been doing it for 11 years.
Good deal. Just a couple of quick service announcements. We recorded this presentation. It's being recorded now. So we will post this on the MAS YouTube site in a few days for people that either joined late or missed this presentation. I want to also say the next BSIG presentation will be on Saturday, February 19th at 1 p.m. Doug Neverman is going to present on beginner imaging and how to get into imaging for people that are interested in that. Actually, an important point is that our observing field that we use for our BSIG monthly observing programs is called Metcalf Field. And we're expecting to get AC power restored back there in the next couple of weeks, according to Excel Energy. So members have access to that 24/7. So once we get AC power there, you can go there and either do imaging or use your scope that has a tracking mount, what have you. And the last thing I want to mention is if people want to help out at a future BSIG observing session, please see me. We always need volunteers. We'll be starting to go back outside in April or May, depending on the weather, and we could use your help. Now, with that, does anybody have any more questions? Come on, Jerry's a really good source. Pepper him with questions, people.
Well, so that means that either I was so clear or I was too muddy. One of the
No,
two.
you're pretty clear. I counted 39 people.
Pretty clear. So Jerry, when you want to go out, what's your first thought? Do you look for whatever constellation comes up? Do you look at whatever's on your list next? I mean, what's your first thing that you think about when you start wanting to plan your night?
So oftentimes location is one of the first things that will come to mind. It's delightful to have a backyard observatory because I wind up going there more often than not. And so I'm already limited. But if I were to say to myself, tonight I'm going to go to Cherry Grove, that would completely change what I would do. So probably weather and light pollution are the two main elements. And once I make that decision, that really informs everything else. If I'm going to go to a dark enough sky site, then I would take a larger telescope because I would want to do Herschel 2s. If I had in mind to do asteroids, for example, and which is really a cool project. to work on. I would do that here at home because it doesn't require great skies. If I wanted to do nebulae, then I would go someplace else. So it's location is probably the number one thing. Then after that, it becomes then what part of the sky will I see? Where are my sight lines? If I'm going to CGO, I know that north is not very good. And so I will kind of just, if I want to find something in the north, I would prefer to go to up to like O'Brien Observatory, or one the one that's being considered north of the Twin Cities, someplace where I can get those sight lines.
Yeah, Cedar Creek.
Yeah, Cedar Creek. Thank you. If I'm doing Virgo, let's say I want to go after it's spring. I want to go after the galaxies in Virgo. Well, then I would go to CGO.
Yeah.
Because that would give me those sight lines. So it's really a combination of all of those sorts of things. But now, one of the things you need to recognize is that I've done a lot of observing. And so either I choose to be goal-oriented and I have a particular specific intention, or I just go out to have a good time and I just see stuff that I've already seen, which is great. It's fantastic. And I do that sometimes. I don't want to have anything in mind. But I do have, but if I were a beginner, if I think back to my beginning days, my first few years of observing, I would go to the best site that I could get to within my time limitations and driving limitations. Like, for example, I remember spending lots of time at Metcalf. I remember spending lots of time up at JJ Casby because the sight lines are better than Metcalf. Skies are terrible because of Woodbury. I also spent time at CGO, but if I were to go to CGO, I would take a little bit larger telescope because I know that the skies are better.
Right.
And then when I got there, I would have lots of opportunities. I think one of the best suggestions I can make to anyone doing, if they want to do Astronomical League projects, is to do a minimum of 5 at a time. Minimum of 5 at a time. And the reason for that is then you have things to do. Let's say, for example, if you're working on 5 and you go out to Metcalf and you realize there's a huge tree in the way of something I want to look at, and I needed it for this project. Well, you're not skunked, just go to a different project. Right. Oh, I can do this over here because I can see this portion. Or a cloud came through and you didn't expect that cloud. And so opening as many doors as is possible is a real valuable thing when you're doing these. It is a mistake to only work on one Astronomical League project at a time. Minimum of 5.
Jerry, there are a couple more questions I'll drop in for you. Mike asks, and this may be something to open up to the other members too, how to take care of binoculars during and after cold weather viewing. Steve Emmert chimed in and said, opinions may differ, but I would put the lens cap back on while outside to trap the cold air, the cold dry air, bring them in and wipe off the external condensation. Then after they've warmed up, pull off the lens cap and make sure the lenses are dry, or dry them with a lint-free cloth. But no matter what, never trap moist lenses under lens caps or covers for a long time.
Right. And that becomes the key. And that's also the same concept with eyepieces. Excuse me. If you are observing over the course of the night, and typically we'll bring our eyepieces in. As soon as you get them to the warm room, they all get dew on them. You clean off what you can on the outsides, but then I always just take the eyepiece cap and just put it askew, so it dries off. It's going to evaporate into the air. Yep.
It's a good idea. Alan Touchberry asked a question that I haven't seen in 30 years. Do you use a graduated reticle for separation and position angle when you observe double stars? Use an eyepiece with a graduated reticle. I haven't heard that term, graduated reticle, in a generation.
So the answer to that question is No, because I find that the graduated reticle that I have a 12 millimeter Meade astrometric eyepiece. And I find that the graduations are too large. I'll use that eyepiece when I am measuring Venus. When I like for the solar system project, you have to view Venus a bunch of times and you measure its size. You notice whether or not it's increased. So I used that eyepiece for that. The graduations, unless it's a super quality graduation and it's laser etched, the spaces are going to be, for many of the double stars, too close. Mm-hmm. You're talking seconds, arc seconds, rather than arc minutes, and so you're more limited by the seeing than anything, and then it becomes an issue of just of knowing what the field of view. If your field of view of your eyepiece is 1,000 seconds, for example, or 100 seconds, then you just, how is that a tenth of it? Is it an eighth of it? Is it a quarter of it? Sort of.
As you mentioned earlier, you can get pretty close to the right answer just using your eyes and using your tracking motor. Because once you turn off the tracking motor, the object drifts west. So now you know where west is. So that's 270 degrees of PA. 90 is east. Then you just have to determine which way is south, and that'd be 180. Then north, and then you can make a guess, and you can get pretty close doing that.
Absolutely, yeah. On the PA.
And you do that not only with double stars, but also with comets, with measuring their tails or their nuclei, their coma. You can measure the PA doing the same exact method.
Now, I hope I may have misunderstood her question. I thought she was asking a question of angular separation.
That's what I could ask too.
If you're talking about position angle, you certainly could use an astrometric eyepiece if the eyepiece has the degrees all the way around. There'd be no reason why you couldn't use that. In fact, that would be real beneficial. My astrometric eyepiece is not good enough quality to split double stars the way I would like to have them split. So I just use the thing on the outside.
Alan, did that answer your question? Feel free to just chime in verbally.
Yeah, it did. I have a Celestron microguide, which has an angular scale and a linear scale. And on a C8 with, a 2,000 millimeter focal length, you can pick up separations on the order of just a few arc seconds.
Excellent.
Perfect.
If it's a good quality, I would use that. If I had it, I would use it because that's going to give me the most qualitative definition.
Don Gadzik has a comment about sorry, I cut you off, Jerry. I didn't mean to do that.
So, as opposed to subjective. It's subjective anytime you're I'm looking at in the eyepiece and then out of the eyepiece and in the eyepiece and but if it's right in the eyepiece, then it's so quantitative and qualitative. I would if I had that eyepiece, I would use it. And if I liked how it split stars.
Don Gadzik has a comment about the Herschel 400. One of the nice things he likes about that list is that until you get to the end, there's always something to find.
Yes.
There's all different kinds of objects and the like. Steve Schmidt.
Yeah. In fact, regarding the Herschel 400, I found that when I would go to a dark sky site, if I got tired of looking at whatever I was looking, I would do some Herschel 400s because I didn't force myself to do such detailed logs or sketches. And then when I got tired of that, I'd move on to something else.
Steve Schmidt asked, since you mentioned the O'Brien Observatory, is that publicly accessible?
Well,
does anybody know the answer to that?
There's no gate.
Isn't that through the U of M still, or is that not
Correct.
through the U of M?
It's still owned by
so
the
maybe
U of M.
the answer is to talk to the U of M. Probably the Department of Astrophysics again.
Yeah, legally. Yeah, I don't know. Maybe I should.
Anybody know the answer to that? Okay, I'll just move on then. Sorry, Steve, we don't know. Steve Emmert mentions, asks, can you stop a typical computerized GoTo German equatorial mount like the Celestron AVX or CGE, so you can check the drift, then restart it without having to realign it?
So
The answer is yes.
the answer is depends. Some you can and some you can't. Unfortunately, I cannot do that with my C11. So I have to go through serious gyrations to find.
But you can hit the left button on that, and that'd be west on the hand controller, wouldn't it?
No, not necessarily.
It depends on your eyepiece angle.
Yeah, not necessarily.
Okay.
Yeah, so
And
some of them, the answer to that question is some of them, yes. And German equatorials, typically, yes, absolutely. Some alt-as, depends.
And then he follows up by asking if you had mentioned Crex Meadows, and would you say that is a good place to go observing projects? Don Gadzik chimes in and says Crex Meadows is excellent, very good horizons, generally pretty quiet, almost as dark as LLCC, nobly better than CGO. There's just no power and no potty.
Correct.
And Trina says lots of bugs.
The only caveat that I would add to that is don't go in July and August unless you have 15 thermocells going all at the same time and you put on 2 inches of bug dope.
Yep,
And
that's what Don says. Don't go there from May to August.
Yep. And you don't mind having 5,000 little observing friends who are buzzing in your ears. I mean, I distinctly have a very vivid memory of going up there, and this was the first time I did it in the summertime, and I literally had to make the decision. Okay, I'm either going to and I was doped up, and I had my thermocell going, so they weren't biting me, but there was a cloud everywhere around me, and they were buzzing, and I remember specifically having to tell myself, okay, you have one of 2 choices. Either see them as your little observing friends or run around screaming because you're freaking out. And I decided to see them as my little observing friends. And so I had thousands of observing friends that night. I never went back at that time.
So the people that have been to Crex, does it really get worse than the ELO does in the summertime sometimes?
Yes. Yes. It's a swamp.
Well,
Crex Meadow is a hillock in a swamp.
Maybe I've just been very lucky, but I've never had a problem with mosquitoes at Crex Meadows.
Really? Dick, you haven't?
Yes. No, I haven't. Believe it or
Amazing.
not.
Amazing.
But I haven't been there that many times, maybe 10 or so.
When's the last time you were there?
A couple years.
I have been there lots of times, and it is my favorite place to observe. My favorite place to observe, except if I'm going to go in the summertime, man, I got to be ready. Mentally.
So it's a new object. It's a mosquito nebula.
Oh man, you got that right. But it is a magnificent place. Their sight lines are absolutely horizon to horizon. There's one little tree that gets in the way. And there aren't very many people that show up, although you do every now and again have to work with the guy in the truck that comes in at 1 o'clock and puts his brights on and drives up to you and walks up and says, "What are you doing, man?" So I typically, when I go up there, I have a sign that I take that says, "Astronomer at work, please turn off your headlights." And that's
great. Well, that's all I see in the comments and the questions, really. Does anybody else have any questions or comments?
Yeah, Suresh, this is Matt. I have a little bit more involved question. So since Jerry has mentioned CGO as an observing site, I guess I wanted to ask either Trina or somebody else, if you're a member, I know you have access and there's rules about use of the site. And can you guys kind of refresh what the rules are for members, whether they're key holders or not?
At
That sounds like a job for
CGO,
Trina.
yeah, sorry, I had to find the unmute button. At CGO, you should be a member. We're not going to run public people off the property, but we just ask everybody to respect the property. But it is a members-based site, and if you go down there, you can use the property, the outside, and park there wherever you need to, and put up your telescope on the new concrete pads that are there. If you're going to need the warming house, we ask that you do a little bit of a training program to get some details about the procedures that are there. But that's still forthcoming for the year. And if you want to get into the observatory, that's a separate training session. So that way you can get access to use one of the 3 telescopes that are in there. But otherwise, the grounds themselves, just drive up, set up, and enjoy your night.
Great. And then Mike Glazer asks a follow-up to Crex. Is there a particular place in Crex to stop and observe, or do you just pull off the side of the road somewhere?
Yes, it's called Rigel Overlook. And if you Google Crex Meadow Rigel Overlook, I think you'll find it. I can post on one of the sites the longitude and latitude, or a photograph, a Google Maps photograph. But yes, it's a parking lot, and it's a good sized parking lot.
Even though it's now an official MAS site, we might want to consider putting a page on the forums for people to find it.
Yeah, I wondered about that. If we want to do anything more than just that, I think we need to contact Crex Meadow, just so they know.
So we get a lot of
publicizing.
We get a lot of requests, especially through the BSIG, for people that want to see the Northern Lights, for example.
Right.
Crex would be an excellent place for that up north, away from the cities.
Yep. The only downside of Crex is that there's a 10-degree light dome south of Grantsburg, Wisconsin, and so that can mess up seeing the tail of Scorpius. And there are some red lighted antennae, and Hinckley is just a very small, very thin light dome. But beyond that, it's a great place. It's one of the few places that I can go that I get a sense of the dome of the sky.
How far away is that? Is that still like a 2-hour drive from the cities?
So it's an hour and a half from Stillwater.
Okay.
The way to do it from the cities would be to go up 35 to 70, I believe, east on 70 to Grantsburg.
I know it's 90 miles from Hopkins because I've looked at that on the map.
Okay.
Yeah, so it's a drive, and it's a drive, and it's more of a drive at 2 o'clock in the morning.
Yeah.
Yeah, it's about 1.5 times as far as TGO.
Yeah.
It depends upon where you are. For me, it's going to CGO and going to Crex are a wash. They're the same, just because of where I'm located. But
it looks like Don put a link out on the chat to the actual location if people want to see it.
Fantastic, thank you.
Well, guys, we're at the top of the hour here. Jerry, this was fantastic.
Thank you.
We have one more question. It looks like it just popped up. Mary Lynn here. Is there a particularly good project for a very casual beginner observer who has no intention or desire to go for a pin or recognition? I have a 4-inch Takahashi, wow, and a full set of Pentax. I know.
Jeez.
Yeah, so there you go.
Oh, Mary,
start with the Rolls Royce.
Mary, once you get a pin, you're going to love it. Trust me.
So I would start out with someone who doesn't have it. If you don't have a lot of experience, but sounds like if you have a talk, you have some experience. The Messier, I would do the Messier list. Now you don't have to do it. You don't have to do it star hopping. You do have to do it star hopping if you want to get the pin and the certificate, but you can just do it. Another one I would do would be the Caldwell, especially when you've got a 4-inch top. A lot of those are gonna pull out. Again, AL requires you to star hop, but you don't have to star hop. So those would be ones that I would start with. And again, so much of it depends on what are you interested in. Summertime. It's summer. Globular clusters. Refractors are amazing for globular clusters.
Great answer.
So go out and look at a bunch of globular clusters. Today, at this time of the year, open clusters. The last, I think the last, either last month's or this month's Stein telescope or last month's or this month's astronomy had a special presentation on open clusters. And again, refractors are amazing on open clusters. So, and there is an open cluster list, and you can use GoTo on that. But so I just say, go for it. What are you interested in? There are more, the ones like double stars and multiple stars and variable stars and carbon stars. Well, not so much carbon stars. There's some a little more esoteric that aren't quite the fun picture. Although carbon stars are fun in the sense of, and again, refractors would be amazing on carbon stars. You slew to the spot where there's a carbon star and you go, oh, there it is. How do I know? It's red. Oh, that's kind of cool. It's red. And
I was going to say, Trina's done some interesting lists recently. Trina, which ones have you done recently that could maybe help Mary Lynn?
I've done lunar. That's the best one, especially if you can handle the moon. The Messier. I'm working on the double star. I'm working on the constellation hunter, which doesn't require any telescope. Because
you got a talk in your backyard. You want to use it.
Well, yeah, true, definitely. I would definitely go for the double stars because those are nice and easy and they're pretty.
Yeah, that's true.
The carbon stars, I did find out that not all carbon stars are red. There's
That's
different variations of it. So
not all carbon stars are red, but the bigger your telescope, the more red you're going to see.
Yeah, I can't wait to do that one.
Yeah,
I think for the Takahashi, the red will really show. The color will really show.
Oh, it'll probably pop.
And then I'd say the globular clusters. Yeah.
Globular, of course, you can't do that until May.
Yeah, exactly. But
that's a summer, but so really the question becomes, do you want to look at pretty things? The bright nebula, there are a lot of bright nebula you can see.
Or right now you can start with Orion.
Exactly. And there are a couple of bright nebula in Orion.
Yeah, and at least 3, I think.
And so really.
Oh yeah.
And there's a situation where there are a lot of bright nebulae you could see. There are a lot of them you can't see because it's going to require more than 4 inches. But there's a lot of stuff you can do.
Circling back on the globular list, isn't that still Bob Kerr as the chair?
Yeah.
And he's here. Bob Kerr is a MAS member. He's the chair for the Astronomical League Globular Cluster Program. I just think that's pretty cool. You can talk to him about them.
Yep. And he's also the chair. He's also the national coordinator for the Advanced Binocular Double Star, which is a challenging project.
I bet. Well, we're at the top of the hour, and I don't see any more questions. Jerry, this was wonderful. You did a wonderful.
So the last thing. Oh, will it do it? Come on, wake up. There.
Yes.
Get out there and observe.
I was waiting.
You were waiting. Awesome. All right, I will give this back to you, Suresh.
Good deal. No, that's it. Everybody, the next one is on February 19th at 1 p.m. We hope to see you there. Jerry, thank you so much.
My
and everybody else for chiming in with questions and comments. I think this went really great. Again, this will be posted on the MAS YouTube channel in a few days or so. So if you missed part of it or want to see it again, you could do it that way. And if you have any questions for the BSIG, please feel free to follow up with me. And I think Jerry gave his email out earlier. If you have questions about his presentation, either reach out to me and I'll reach out to Jerry, or just reach out to Jerry directly.
Yep. Feel free to reach out to me. And you can do that via my email address, jjones7777@aol.com. I'm a dinosaur. Or through the observing forums or however you want to do it.
Yeah, just so people know,
Slack too.
On the MAS forum, Jerry oversees the observing topic. Jerry, what forum page is that on? Is that the observing page?
So all those are on the board list or something like that. It's under,
Mhm.
it'd be under the discussions and you pull down, what is it, under members or something like that. You pull down that and in select discussions.
And so Jerry's always asking people, if you go out and have a good observing night, chime in on the forum and
Right.
let us know what you've seen and
Please do.
and what your observations were.
Yep.
It's a great way to share community with us.
Awesome.
Great, guys. Thank you for your time, everybody. We'll see you again next month.
Thanks.
Bye. Bye, Jerry.
Bye-bye.